Okay, I now have our quiz, and you're asking for number 21. Okay, so the concept here is called the add multiply property, and that applies whenever you're talking about exponential functions. Okay, so it's called the add multiply property. Only for exponential functions. So they have to tell you that you have an exponential function. All right, so add multiply means we're going to add something to the x's and your y's are going to get multiplied by something. So number 21 says assume f is an exponential function with f of 3 equaling 20. Let me make my xy table here. Okay, so let me make this comment. F of 3 equals 20. Some people are going to get the 3 and the 20 in the wrong place when they go to write their XY table. And so we're up to 64 people, you guys. This is great. Okay, so if I say F of X, right? Look at this, F of 3 equals 20. I just said F of X, so doesn't my X have to be 3? So please don't put 20 comma 3 when it's 3 comma 20. Okay, you've got to know which one is your X and which one is your Y. Okay, then they told you that F of 7 is equal to 24, so that gives me the point 724. Okay, so now that I've written those, let me go back and reread this. It says assume F is an exponential function with 320 and 724 as 2 points. It says use the property of exponential functions. They mean the add multiply property that I just wrote right here. And so that means I'm going to look at my x's and say, what got added to 3 to get me 7? 4. And then I'm going to look at my y's. I saw somebody put plus 4, because do you agree if you add 4 to 20, you get 4? Well, that's not the add multiply property. I want to know what 20 got multiplied by in order to give me 24. So if you cannot look at that and know exactly what it is, sometimes you look at it and you're like, oh yeah, it's times 2 or it's times 3 or whatever. If you can just look at it, great. But if you cannot, then you take 24 and you divide it by the previous value of 20 and I get 1.2. So that is my multiplier, or sometimes they'll say, what is the factor? Okay, so now let's look at the rest of the question. It says, use that property to calculate f of 11. So let me write 11 right here. And they also want f of 15. Well, look at how nice they were. If you add 4 to 7, you get 11. If you add 4 to 11, you get 15. So doesn't that mean I'm going to multiply this by 1.2? And then I'm going to multiply that y value also by 1.2. And I'll have the 2 answers that we're looking for right here. Okay, so in my calculator, I'm going to go 1.2 times 24, and I get 28.8. By the way, notice these directions didn't say anything about rounding. Okay, so I'm going to write 28.1. Excuse me, 0.8. It's a terminating decimal. Write the whole thing. Then when I multiply that by 1.2 again, I get 34.56. I don't know why in the world somebody would round that off. They didn't tell you to, and it's a terminating decimal, so write the whole thing. Okay, I had somebody round that off to 34.6. Why? Just write the whole thing. Okay, it's a terminating decimal, and they didn't ask you to round. Now, if I did say round everything to the nearest tenth, okay, then fine, follow the directions. But if they don't tell you to round and it's a terminating decimal, then don't round it off. Okay, Shiloh, I hope that helped. All right, so again, 24, there are 4 parts, okay? You need to be more specific. All right, Caitlin, can I do number 11 on 279? Yes. By the way, with so many people on here, let me just say that if I'm doing something right now and you're like, I have a question about that, and you type it, it might be a half hour before I get to that question. Okay, and so that makes it difficult for me to go back, because a lot of times I don't know which question you're asking about. You're typing it while I'm doing it, so you think I know which one you're talking about, but if I don't get to it until half an hour from now, I'm not going to know which question you're discussing. Okay, so I just wanted to point that out. All right, so 279, number 11. And that is for Caitlin. Okay, so this is a problem that they're asking you to do without a calculator. And so um, they gave different values than what you saw in the test. But so let me just write that they gave us in this problem that log of 2 is approximately 0.301. Okay, so on the test, when you're taking the no calculator part, it might be 0.3 instead of 0.301, just to make it a little bit easier. Okay, and then they also gave you that log of 3 is approximately 0.477. And in the directions, they also told you log of 5, but I can see from this question number 11 that we don't need that. So they're saying without using the log key in your calculator, can you find log of 2/3? Well, you have to know your property of logs, okay? So we've talked about this in my class. There's only 3 properties of logs. If you guys have not made flashcards for the 3 properties of logs, I think you guys are making a big mistake. There are only 3. It's not going to take you very long to write the flashcards, and then you need to practice them. Okay, so I have given names to all of our properties of logs. So the first property is single log of a product. The second property is single log of a quotient. And the third property is a log of a power. That's it, those 3. And I think that knowing the names is very important. So this, look at what I have, log of 2/3. Isn't that a single log of a quotient? Well, you have to know what this expands into. It expands into the log of 2 minus the log of 3. Like there is nothing else to know but that property to be able to write that. Well, now I look at what they've given me and I go, oh, I can just write 0.301 instead of log of 2 and then put my minus sign and then say 0.477. Okay, so let me give you a different example because you're probably thinking, yikes, I have to subtract that without a calculator. Okay, well, let's say on the test we told you that log of 2 was 0.3 instead, and that log of 3 was 0.5 instead. Okay, so now do you agree that shouldn't be that big of a deal to subtract? You would get negative 0.2, and that would be your answer. Okay, that's it, but you've got to know your properties of logs. Okay. Leah, can I do page 293, number 7? Let's start with that. All right, this is asking us to find an inverse. All right, I did just do one, but it was a logarithmic equation, so this is certainly very different. Let me write this down, page 293, number 7. All right, and I'm not going to graph this, okay, because that's going to be very time consuming and I want to get to more questions, but I will show you how to find the inverse. All right, so here's my function that they gave us. Okay, so step 1 is write y instead of f of x. Step 2 is switch your x and your y. Step 3 is solve for y. So first I'm going to take the cube root of this side. So that means I have to take the cube root of that side. So that gives me the cube root of x equals my cube root and my cube cancel. So I get y plus 2. And then I'm going to subtract 2. So I get the cube root of x minus 2. And then instead of y, I'm going to write f inverse of x. Okay, so there's my function. I will tell you that this x plus 2, the quantity cubed, looks something like this. Okay, I'm just going to do a quick sketch without putting points or anything. Okay, and so the inverse of that, I will tell you this, the inverse of that will be a reflection over the line y equals x. So let's say that's what your graph looks like. Here, this dashed line that I'm trying to draw in right now is my line y equals x. And if you kind of turn your head at a 45-degree angle, you go, oh yeah, I see that reflection. Okay, so when they ask you to graph a function and its inverse, let me point this out, that your x and your y scale must be the same. You cannot say, oh, I'm going to go by 1s on the x-axis, but then go by 10s on the y-axis. You can't do that. So that you can see this relationship of the reflection over the line y equals x. Okay, Leah, I hope that helped you. Okay, and then page 284. Number 15. Okay, that actually lands on 285. So this is what I call the tricky looking problems that kind of end up being easy, but only if you know your definition of logarithm and properties of logs. Let's see, we said number 15. Is that right? Yeah. Okay, so it says simplify the expression. Here's the expression. It says 3 times the log base 24 of 24 raised to the negative 2/3 power. Okay, so there's a lot going on there. All right, so the 3 in front, that's just a numerical coefficient. I'm not going to do a thing with that right now. But I would be asking you, if we were in class together, what is a name I can give this? Okay, and so I'm looking for one of 3 answers. Leah, I don't know who your teacher is, and it doesn't matter, but I don't know if they emphasize the names of the 3 properties of logs, but they all have names. The first name the book calls a log of a product. I like to emphasize that it's a single log of a product. We also have a log of a quotient, so I like to emphasize that it's a single log of a quotient, because both of those, log of a product and log of a quotient, the other side of the equation is not a single log. You expand it and you get log of this plus log of that, maybe plus another log of something, right? Okay, and then the third property is called a log of a power. Well, look it, that's exactly what we have. We have log base 24 of 24 to an exponent, right? That's called a power. So I personally call that the whistle property. So I'm going to circle this exponent because it's a log of a power. That exponent becomes a coefficient. So I'm going to put negative 2/3 out here, and it's going to be a factor. So times, that's my red dot right there is my big time sign. And so when I whistle that over, now it's in front, it's no longer here. So I've gotten rid of that exponent. Okay, so let me rewrite what I have right now. I have negative 2/3 times 3 times the log base 24 of 24. So again, I'm not sure what you guys have talked about in class, but whenever the base of your log is equal to the argument of your log, that whole thing, log base 24 of 24 equals 1. And I won't go into the definition or the reason why it is. It just is. Okay. 2 things about my base and argument. They cannot, either one of them, be negative. They cannot be 0. And my base also cannot be 1. But so as a general rule, your base and your argument have to be positive. And if they are equal, then the log of that equal base and argument, that whole thing equals 1. So then when I look at this negative 2/3 times 3, I notice that my 3's cancel, because this 3 is a denominator, that 3 is a numerator. So your final answer is negative 2. Okay, and you don't need a calculator to do that, so something like that could be on the no calculator part. By the way, in case any of you are not sure which test is when, tomorrow is the calculator part, and the next day is the no calculator part, which I just realized I'm doing another GVL tomorrow night specifically for the no calculator part. So I shouldn't be doing this problem tonight. We should be concentrating on the calculator stuff. Okay, so let me keep that in mind. Race 20A and B. You are not telling me what. Oh, it must be on the quiz, I'm guessing. That would be helpful to know if you mean the quiz or a page number. 20A and B. Okay, I'm going to assume that's the test, or the quiz rather, and that is on the calculator side, so I am going to do that. Okay, so quiz number 20. All right, so they gave you a function. They're asking for the inverse. I'd like to point out that this is the 3rd time I'm finding an inverse for you guys. So step 1 is write y instead of f of x. Step 2 is switch the x and the y. Step 3 is solve for y. So first I'm going to subtract 5. So I get that. Then I'm going to divide by 2. And you can say all over 2 like this. Okay, so I get y equals that. However, my next part, part B, is going to ask me to graph this. Okay, so let me go ahead and write f inverse, because that's my step 4 instead of the y. But then instead of leaving this as x minus 5 all over 2, I'm going to write it as 1/2 x minus 5 halves, because then isn't this in y equals mx plus b form? Okay, and then I'm going to do a super fast sketch. So for the original function, my y-intercept is 5. My slope is positive 2, so I'm going to go up 2, right 1, and get that point. I'll probably go down 2, left 1, and then take a straight edge. By the way, when you guys are taking your tests tomorrow and Wednesday, I'm just looking to see if you'll need it on both days. I don't know, but if you do have to graph a line, you should have a straight edge with you. Okay, so that's my original function f, so I'm just going to put an f right there. I know that's not very straight. I apologize. It's hard to draw on this thing. Okay, so then my inverse function rather, I have a y-intercept of negative 2.5. So I'm going to put a point there, and then my slope is 1/2. So I'm going to go up 1, right 2. You have to be very careful because we're just estimating with that non-integer y-intercept. If I go up 1 and right 2, I've got a point here. Okay, so I'm just going to kind of do it quick, but I would use a straight edge, okay? And make your lines long enough so you can show their intersection. And then again, so you guys should be experts at this on test day, if you have to graph lines showing that they are reflections over each other through the line y equals x, or even if they're not lines, any function and its inverse must be reflections of each other over the line y equals x. So you should draw that dashed line and label it y equals x. Okay, I hope that was helpful. Okay, Sophie, can I do number 4 on the quiz? You know what? Save that for tomorrow night because that's no calculator, and I'm doing another GVL tomorrow night, specifically for no calculator, okay? So Aaron K is asking for 18. That is on the calculator side, so let's do that. Okay, quiz number 18. All right, it says log base 2 of 225 minus log base 2 of 5 plus log base 2 of 3. Okay, so again, if you don't know your properties of logs, you're really going to struggle through this. This is definitely not a single log. Does everybody agree? This is a log minus a log plus a log. Okay, so that's a combination of 2 of my properties, single log of a product and single log of a quotient. So I'm going to put log base 2, I'm going to put parentheses, and I'm going to put a fraction sign because I see some of my coefficients are positive and some are negative. Those positive and negative coefficients of these 3 logs are what determine whether I'm going to put the argument 225 or 5 or 3 in the numerator or denominator of my fraction. So the first log, I'm going to write this in red, doesn't have a plus sign implied in front of it. That means your 225 goes in the numerator. Then I look at my second term, and isn't my coefficient negative? That means my 5 goes in the denominator. Now, if I were to ask you whether 225 and 5 right now are factors or terms, if you know the difference between a factor and a term, terms are separated by plus or minus signs. Factors are separated by multiplication or division signs. And so those are factors. Everything inside your argument here will be a factor if you've done it correctly. Because think about it. We have, let me do it over here in the corner, single log of a product. Here my x and my y are factors. Or single log of a quotient, x divided by y, those are also factors. You don't have one property that's called the single log of a sum. So don't make it up, okay? Because here's the mistake coming up right here. When I look at my third term, I see that my coefficient of my log is a plus sign, okay? It's positive 1. That means my 3 goes in the numerator, and many of you are going to write plus 3. That would be single log of a sum. It never is that. So it's times 3. They are factors. See, that's a single log of a product, and then we also have of the quotient because of the minus sign in front of log base 2 of 5. Okay, so then you simplify that, 225 times 3 divided by 5, and that's what you can use your calculator for, and you get 135. Okay, and that's all they wanted. So don't you dare do the change of base formula and go, oh, this equals whatever decimal that is. Okay, they didn't ask that. They said write as a logarithm of a single argument. So there's your answer. Okay, Aaron, I hope that was helpful. Okay, Geo, will I be doing a GVL tomorrow for no calculator? Yes, I just announced that. So tomorrow, 7:30 to 8:30, specifically for the no calculator part. Okay, and I probably did, I wasn't even paying attention. I was just answering your questions. If I did any questions tonight that were no calculator, I think I probably did. That's not going to be on tomorrow's test, okay? Okay, Kyla, I'm not sure how to say your name, probably Kyla. Can I do 11 on the quiz? I think, nope, haven't done that. I did do it in class, but okay, so quiz number 11. All right. Oh, that's no calculator. I just said I'm not going to do that. Okay, ask tomorrow, okay, Kyla? All right, Ellen, number 17. That is no calculator, so please ask tomorrow. Okay, and then Kyla, number 23 on the quiz. Yes. Okay, so let me just write right here. Actually, let me erase these. Okay, quiz number 23. Here we go. It says solve for x and round to the nearest hundredth. Okay, so please understand, I'm not ignoring your questions. I'm just focusing on the calculator stuff because that's what tomorrow's part of the test is. Okay, so it says 2 times 8 to the x equals 19. You have to know that your first step must be to divide through by whatever that a is, if there is an a. Okay, so my 2's are gone now because those are factors. You have to get a base and an exponent all alone, and then you certainly can write that 19 over 2 is 9.5, but I'm just going to leave it as 19 over 2. Okay, if you cannot change this exponential equation to logarithmic form, I'm just telling you right now, you are probably going to fail your test tomorrow. So I strongly suggest that you really, really, really make sure you know your definition of logarithm. Okay, that's an exponential equation. 8 to the x equals, let me just change this to 9.5. All right, and I'm now going to change it to logarithmic form. So it's log base 8 of 9.5 equals x. I'm not going to go into the reason why that is. That's just the definition of logarithm. Okay, and you guys should have talked about that in your classes, and y'all should know how to do that. Okay, but I don't have a log base 8 button in my calculator, so next I have to know my change of base formula. So I want to emphasize that the change of base formula has 2 logs in it. I was helping somebody today after school, and that's the first thing she wrote down was the fraction sign, and then she wrote a log up here and a log down here. That's a great idea to do so you don't accidentally go making up your own rules. Okay, the change of base formula is what it is. Don't go making things up. Okay, so I'm going to change the base to base 10 because I have that key in my calculator. And so you must know that the 9.5 goes up here and the 8 goes down here. And then you also must know how to enter this in your calculator. So I hit log, my calculator automatically puts the left parenthesis. I'm going to enter 9.5. And then if you don't close the parentheses or hit equals, you're going to get this wrong. So I close the parentheses and then I hit divided by log of 8. Now I can just hit enter. You don't have to close your parentheses on the last one because you're hitting enter. All right, so this is approximately, this is an approximation, you guys, but they specifically told you to round to the nearest hundredth. So I'm going to, and it's 1.08. My next number is 2, so that doesn't change the 8. So 1.08 is my approximation. And then here's the beautiful part, you guys. Say you're done with your test and you're like, oh my gosh, I still have 15 minutes left. Well, take that 1.08 and see if it makes sense. Okay, so I'm using purposely the rounded off values. So when I enter my 2 times 8 to the 1.08, I'm not expecting to get exactly 19, but it better be pretty close. 2 times 8 caret 1.08. And look at that, I got 18.9 if I round to the nearest 10. So that is pretty close to 19. Okay, it's an approximation, so I was not expecting it to be exact. Okay, but it should be pretty close. Okay, Kyla, I hope that was helpful. I have a feeling there's a lot of questions I'm not going to get to. I can see that. Okay, some of those comments are you guys talking to each other. Okay. Find back where I was. So Leah, I just saw yours. Would you multiply by 24 over 20? We did 24 divided by 20. Yeah, that was our 1.2. And that was exactly 1.2. Okay, I got back to where we were. All right, so Marion is asking for number 3 on page 304. So I need to make sure that this is a calculator question. Oh, I sure hope it's not a word problem. Yeah. We only have 20 minutes left, so yeah, I don't think, I mean, if I do this, we'll probably spend the entire time on this. Did we do an example yet of finding an equation? Let me just do this, I guess. Let me find the equation, okay? So first of all, here's the general equation of an exponential function. Y equals a times b to the x. In order to solve for the a and the b, those are my missing parts, you have to have a point that is 0 comma something, or else you cannot do this problem. Okay, so anytime you're doing one of these problems, this is the car stopping problem that Marion is asking about. The x value is going to be like, well, let me just do it. Oliver Sutton, did you get that? They do cute things like that. Oliver Sutton. Okay, Oliver Sutton is driving along a straight level highway at 64 kilometers per hour when his car runs out of gas. As he slows down, his speed decreases exponentially. This sentence I'm reading right now is going to tell me what is my y and what is my x, and I'm going to write that in words. Okay, so as he slows down, his speed decreases exponentially. As soon as I see that, I know speed is my y, because y, they're telling me, is an exponential function in terms of x. So decreases exponentially with the number of seconds since he ran out of gas. Okay, so I'm going to put seconds here, but I'm going to write in parentheses, since he ran out of gas. I'm really just writing that to emphasize to you guys, okay? So seconds since he ran out of gas. Okay, so it says that as he slows down, his speed decreases, dropping to 48 kilometers per hour after 10 seconds. Okay, so when he first runs out of gas, his speed was 64 kilometers per hour. So that's my 0, 64. That's when he first ran out of gas. And then they tell us 10 seconds later, so seconds is my x, he drops down to 48 kilometers per hour. Okay, since they told me this was exponential, they could ask you questions about, what about after 20 seconds? Now they asked for 25, since that's not an add 10 and then add 10 again. Oh, hi, Bear. I think all 65 of these students want to meet you. Bear, come here. Come here. Come here. This is my puppy. Hi, Bear. Hi. Say hi to my students. Hi, everybody. Do well on your test. Oh, he's bored. Ha, like you guys. No, Bear loves math. It's fun, huh, Bear? Okay. Okay, that was puppy break time. All right. So sometimes in a situation like this, they'll ask you a question about like 20 seconds or 30 seconds where you can just look at the pattern and figure it out, okay? However, here we're trying to come up with the equation. So I'm going to plug in the 0.64 into this equation. Let me do this in red. So 64 is my y. A and b I don't know. 0 is my x. Isn't b to the 0 equal to 1? So we now know that a is 64. So let me bring that down here. So right now I know y equals 64 times b to the x. And I'm going to plug in my second equation, or my second point rather. Y is 48 times 64 times b raised to the 10th power. You have to divide by 64. Okay, so I have b to the 10th equals, I don't want to make mistakes. I'm so tired, you guys. I just finished another GVL right before you guys. So I'm going to let my calculator simplify this for me because, okay, so I get 3/4 or 0.75. Okay, so 0.75. And next I'm going to take the 10th root to get my b. And so technically you're not supposed to have a decimal inside of a radical. And if you had written the 0.75 as 3/4, you're not supposed to have a fraction inside of a radical either. However, I want your equation to be exact. So I'm going to write y equals, my a is 64, my b, I'm going to write the 10th root of 0.75. Now I'll probably enter that in my calculator and store it, but I want you to write your equation like this. Because there's so much going on there, I think I'm going to put that in parentheses and then say raised to the x power. Okay, so I just wanted to show you how to enter that, or how I want you to write it. Okay, but now if I enter the 10th root of, and make sure you know how to do that in your calculator, 0.75, I get approximately 0.97. I had somebody on the quiz round off the B part right here. It was 0.99 on the quiz, but say they rounded it off to 0.97 in this problem. When you go and raise that rounded off value to some pretty high power for x, it's going to be so inaccurate. You guys, you cannot do that, okay? So if you're going to punch that into your calculator, you need to store it, okay, and use that stored value, not the approximation. Okay, I'm going to be honest. I don't know what you raising your hand is supposed to tell me, because I don't know what you've written and where. So the raising hand thing doesn't tell me anything. Sorry. Okay. So I think I'm going to stop there, Marion. So I hope that was helpful to at least do that much. Okay. All right. Let's see. Okay. And I see your comment, Matthias, that you raised your hand on accident. Okay. So Marion is also asking for R14. If there's an A, B, and C, I'm not going to do it. Yeah, there's a lot, and that's a word problem. We just don't have time for that. I'm sorry. I did do this word problem, okay? I just can't keep doing all these word problems. We'd be here for 3 hours. Okay, so I'm going to move on. Ooh, Kai told me part C. Now I have to go back and find Kai's question. Okay, it was R12, part C. Okay, it is another inverse function. So apparently you guys don't get inverse functions, huh? All right, I feel like this is probably about my 4th inverse function. R12, part C. Okay, they gave you h of x. I'm going to write y right away because that's my first step in finding an inverse, is write y instead of the h of x. So y equals x squared. But they tell you that x is greater than or equal to 0. Okay, so we'll come back to that. It says sketch the graphs of h and h inverse. Well, I was just going to say, so, oh, actually, they didn't ask you to find h inverse. Well, if we have to graph it, sure, we have to find it. Okay, so I've already written y. I'm going to switch my x into my y. That's step 2. And then I have to solve for y. So to solve for y, I need to take the square root of both sides. Normally, when I take the square root of both sides of a quadratic, I always say, but don't forget plus or minus. Yeah, I'm making that really big because it's such a big deal. You're solving a quadratic equation. Of course, you should have 2 answers. However, in this problem, because they said to let x be greater than or equal to 0 for the original function, since we're switching our x's and y's to find this inverse function, that means that I need to make my y greater than or equal to 0. So for that reason, we're going to drop the negative part. Okay, but otherwise, when you take the square root of both sides of a quadratic, you do say, don't forget plus or minus. So I'm just going to have the positive square root of x. All right, so then this original function was h of x, I think. So instead of writing f inverse, I'm going to write h inverse of x equals just the principal square root of x. I'm kind of writing that plus sign for emphasis. You don't have to write it. It's implied. Okay, so very quickly, I'm just going to do a quick sketch of this, okay? I would plug in values for x for my original function. I already know that's going to be a parabola that opens up, but since they specified only x's that are greater than or equal to 0, I only get the right half of that function. Okay, when I draw the function, the inverse function h inverse, I'm going to end up getting this half of the parabola. And notice that that is a beautiful reflection over the line y equals x. Okay, so if nothing else from this GVL, you guys should be experts at realizing that when you draw a graph of a function and its inverse, they better be reflections of each other over that line y equals x. Okay. Okay. This question. Ellen, can we go over the properties of logs? Guess so. All right, I'm going to write them really fast. So it's single log of a product, or single log of a quotient, or log of a power. I forget what letters they use. I'm going to go x to the n. Okay, here's the single log of a product. It becomes log of x plus sign log of y. Notice that right side is no longer a single log. Okay, that's why I emphasize on the left side, that's a single log of a product, and it turns into that expanded form. This single log of a quotient ends up being log of x minus log of y. Okay, so I'm going to go through the right side of both of those equations, and in red, I'm going to emphasize their coefficients. Isn't this first log a plus sign implied? The second log, you can see it's a plus sign. The third log, it's also a plus sign. The only one that's not a plus sign is this minus sign right here, right? Okay, so look at all those red plus signs. I'm going to box the argument here and here and here. Hey, Jordan, can you please stop raising your hand because it's kind of in my way. And then I'm going to box them on the single log side. Okay, here's my x, here's my y, and here's my other x. Notice those are all numerators. Okay, that's what you need to know, because if you are given the expanded form and asked to go back and write it as a single log, you have to know that the arguments will all be numerators. Okay, now because this minus sign in front of this fourth term, this fourth log, that y that I'm boxing in green, notice where it is. It is in the denominator. So, moral of the story is when they write it in expanded form, okay, when they write it in expanded form and ask you to write a single log, if the coefficient is negative, the argument goes in the denominator of your single log of a quotient. But if your coefficient of your expanded form logs are plus signs, then this goes in the numerator, this goes in the numerator, and this goes in the numerator. Okay, all right, enough with those two properties. So log of a power, that n goes to the front and becomes a coefficient. Okay, so I kind of just made a mess of that, so let me rewrite it. So if I have log of x to the n, it is equal to n times the log of x. Sorry, my brother just got here. And so there you go. Oh, are you guys having problems with the connection? I just saw somebody say, why do we keep disconnecting or reconnecting? Okay, I still don't know why a bunch of you keep raising your hands. I don't know if that's on accident, but it gets in the way of my screen, so I'm taking you off. Okay, so Ellen, those are your three properties of logs. There are only three of them. You guys, you have to know those, or you're going to miss all those problems that apply the properties, and that's really sad because those should be easy, but if you don't know your properties, you're really going to struggle. Okay, we've got about 7 minutes left. Okay, so let me see where we are. Oh, I just saw Preston. There aren't a lot of people with names Preston. Preston, my son's name is Weston, and there aren't a lot of Westons either. Okay. Okay, Brandon, no, we are not going to do one of those really long word problems, just because I'm trying to get to as many questions as I can for you guys. I did do part of one word problem, and so that's all I'm going to do for the word problems. Okay, do we have to graph exponential equations? Yeah, you should be able to, absolutely. You've got increasing exponential equations, we just asked that, Jordan, and decreasing exponential functions. So I'll just do a quick little sketch. This is an increasing exponential function, and it approaches the x-axis over here. And here's a decreasing exponential function, and it approaches the x-axis over here. Okay, and what makes it increase? If your base is bigger than 1. So there's just an example. What makes it decrease? If your base is between 0 and 1. So those are just two examples to show you quickly. Okay, but I would make an XY table. I would suggest for your exponent x that you do some negatives, 0 and some positives, so that you get a good variety of your graph. So say I was doing this increasing one, 2 to the negative 2 is 1/4, 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So then I would go when x is negative 2, there's my 1/4, super tiny number. When x is negative 1, I'm at 1/2. When x is 0, I'm at 1. When x is 1, I'm at 2. And then when x is 2, that's where it kind of goes way up there. And you can see that those points all landed on my little sketch. Okay, and then you would do the same thing for this, a little bit trickier when your base is a fraction. Negative exponents, remember, mean the reciprocal of that base, and then squared or cubed or whatever. Okay, Jordan, I hope that helped. Okay, Stephanie, can I do 23 on the quiz? All right, find that. I already did that one. Yep, I already did that. Okay, Geo, can I go over R4? I think letter B, the one that starts with 9 times 1/2. Okay, R4. Oh, 9x to the, I got you. Okay, so it is actually R4D part 3. Next, yeah. Okay, so this is page 318, number R4D part 3. Okay, so it says 9 times x to the negative 1/2 times 16 times x to the positive 1/4 times 5 x to the 0. Okay, so all of these are factors. Remember we said factors are multiplied or divided. Terms are separated by plus or minus signs. So these are all factors, and you can multiply factors in any order. So I'm going to multiply my 9 times my 16 times my 5 because those are all numerical coefficients. So 9 times 16 times 5 equals 720. All right, so that's my coefficient. Okay, and then when I look at all these x's, I personally say my properties with words, not trying to just memorize some algorithm. So here are my words for this property. It says when multiplying like bases, you keep the same base, so there's my x, and then you add the exponents. So I want to add negative 1/2 plus 1/4, technically plus 0, okay? Or I could have just taken this x to the 0 and said, hey, that cancels out because it equals 1, okay? And then I wouldn't have had the plus 0. So in this 720x, and now my exponent, I'm going to rewrite that negative 1/2 as negative 2/4 so that I can add it to positive 1/4, and so I get 720x to the negative 1/4 power. So if their directions say write your answer so that there are no variables in the denominator, then that would be your answer. If, however, they say write your answer so you have no negative exponents, then I would rewrite this as 720 over x to the positive 1/4. Okay, and here's your little bonus for being on GVL tonight. I'm telling you that the directions on the test are going to say no negative exponents. So this green box is the final answer. Okay, Geo, I hope that helped. All right, I think Race is going to get the last question of the night. 19 on the quiz. Okay, that's actually an excellent question. All right, so, oops, this is quiz. All right, quiz number 19. Okay, and this goes back to Ellen's question about reviewing the properties of logs. So it says 4 times log base 8 of 3 minus log base 8 of 6. All right, if you go back and look at the properties of logs that we talked about, on the expanded side, not one of them had a 4 in front of the log. It was either a plus sign and then a log, or a minus sign and then a log, but you never had a numerical coefficient. So that means I cannot apply my property of logs on this until I get rid of that 4. So I am going to reverse whistle this 4 to right here. It becomes my exponent of the 3, and now this 4 is gone. Okay, so let me rewrite this. Now I have a log base 8 of 3 to the 4th. Well, that equals 81, minus log base 8 of 6. And by the way, if you go 81 minus 6 and get 75, you're not doing anything that other students haven't done. It's called making up your own properties of logs, and they are completely wrong. So please don't do that. Practice your 3. There are only 3. Practice your 3 properties of logs. This is going to condense into a single log. So it's going to be log base 8 of a quotient because of that minus sign, right? We said if there's a plus sign, I'm going to use the same colors I used on that analysis of the properties of logs. There's a plus sign implied there, so that 81 goes in the numerator. And then in front of my second log, that's a minus sign. So my 6 goes in the denominator, okay? That's knowing my property of logs, property or log of a quotient. All right, and then I just want to simplify my 81 over 6, and so 13.5, or you certainly could write 27 halves, okay? And that ends up being your final answer, single log of a quotient, okay? All right. Yeah. Okay, I think we're going to stop there. It's 8:31. I hope that was helpful for you guys. Yeah, with 60 plus people, it's difficult to get to everybody's questions, so I'm sure somebody feels gypped that I didn't get to yours. Sorry. If any of you need some extra help before test day, tomorrow morning in room 406, Mrs. Dunkel is doing before school help. She gets there at 6:50. You can get there at any time you want, but if you have a few extra questions that you want to ask, she can help you. All right, I hope you guys have a nice evening, and